All right, let's have a look at how to set this scene up. It's a number of mannequins, and as you can see in the outliner, there's like a little Newton field that sort of pulls them all together and also drags them along the ground. And I've modified a few of the defaults. So the friction, for example, is very high, so that when they are sort of sliding around along the ground, they'll actually roll rather than slide. Other than that, these are just the default mannequins that ship with Ragdoll. So let me throw this together from scratch so you can see what's going on. So for starters, I'm just going to grab the mannequin character, and I'm going to grab a couple of these. So something like that. I don't know how many there are. I don't know, 8 or something of sorts. By default, you'll get the sort of standard falling to the ground behavior if we hide the meshes and hide the joints. Actually, before we hide the joints, I'm going to scale the ground. So by default, the scale channel is locked on anything that you load, but you can just unlock it. So now they're not going to fall off screen, and we can make it a bit bigger because I want it to roll quite a bit. The next thing to do is just to get one of the Newton fields in here. So right off the bat, you'll see that they get this little arrow giving you a hint as to what's about to happen. So when I hit play now, they are subtly drawn towards that point. If I put it over here, you get a slightly different effect. And so the magic is to increase this. You know, as you increase, you can see that the force sort of gets a lot larger. And I think we'll probably want it to be very large in this case. In the example, I think I used a value of 40 or so. Yeah, something like that should be fine. I get a lot of wobble. Like I kind of want them to be pulled towards the point and then kind of come to a stop. So I'm going to crank up the air density on the solver for that. Something like that. And now if you were to pull this around, you can kind of see the effect we're going for. Some of them are already rolling. Actually, let me just change the draw scale on these forces, because now we're working with such large forces that the draw size becomes really large. There's a little multiplier here you can use, but this one I think it needs to happen on the start frame. Yeah. So now when we basically just multiply this little arrow. We're not actually changing the force. We're just changing the way that they're drawn. So now it looks a bit more manageable. All right, so they're all pulled to the center, and we can pull them on the ground. But like I said, they're not really dragging. They're not really sort of getting. They're not rotating. They're not rolling. So next step, I'm just going to go ragdoll, select all the markers that I have in my scene. And I'm going to set friction to the highest value of, highest value. So technically, a friction of 1 means that there's no sliding whatsoever. But normally, in this case, I think we want to go beyond that. We want to sort of create sort of a sticky surface. We want to guarantee that anything that touches the ground. So you see, we get some pretty decent rolling, but some of them are still sliding. So you can sort of crank friction up beyond a value of 1, and it just does what you expect it to do. So I'm just going to give it a value of 5. So now I would expect there's no sliding going on. Everything is going to be rolling, and yeah, that looks pretty decent. And okay, so that's it. Now we're going to create some pre-roll. We're going to have them all gather for maybe, I don't know, 40 or so frames until they come to rest. And then at frame 40, I'm going to take this locator and just crank it down into the ground. Whoop. There we go. So now we have our starting position. From here, I'm going to get him to slide, say in this direction over here. And you'll notice that I have the forces below the ground, because it's sort of, I want to pull them into the ground. So because if I left it up here, they'd be pulled. You know, the characters that are on the ground will get pulled upwards, and that's not what I want. I want everything to be pulled downwards, so that's why the force, like the target that they're all trying to reach, is below the ground. But obviously the ground is keeping them from reaching it. At this point I realized that some of the defaults of the forces are not suitable for what we're doing, because the force is so large we get some jittering happening. So there's a slight optimization in Ragdoll to make forces run faster, but in this case, that optimization is actually causing these stutters to happen. You see, they're very nervous looking on the ground. And to solve that, I'm just going to go to the solver, and in the advanced tab, there's a checkbox to compute the force on every substep. And that just means that if you have many substeps, I have 4 in this case, the field will be computed on each of these individual steps. I know it's a bit technical, but generally you can keep that ticked all the time. It doesn't really impact performance all that much, and I think probably it's going to be the default moving forward. As a consequence of being computed every substep, it's also 4 times as large, like the force becomes multiplied by that. So let's have it. I think that should be sufficient. So now we have a twice as strong force and no jitter going on. All right, next, when they're around this point, maybe we'll do what I did in the example video, just sliding them all in another direction to create some more interesting behavior. It's probably a bit too fast, something like this. Yeah, and that's pretty good. At the end of that video, I also dropped them to the ground. So like they released themselves from being pulled towards this force and sort of collapsed naturally onto the ground. And you can do that by just animating this magnitude value. So how about when they are almost finished rolling, let's say here, let's drop the force altogether. At this point, there is no force. So I expect them to just get thrown and land on the floor. They're a bit slow motion looking once that happens, because remember we cranked up the air density as well. So let's animate that as well around the point when they all get flung. So here, air density 0. There we go. So now they all get sort of thrown to the ground and then comes to a sort of relaxing state. And I mean, that's pretty much it. So in the video that Jason made, there was one additional addition that I don't have here. You'll notice that all the characters, the original characters, they're not actually moving. In his example, they all had a run cycle on them. So they were sort of running as they were being pulled together, which would have meant that at the end, when they all come to rest, they would have been sort of running on the spot. So you can try animating these guys, like if you were to add, I don't know, some keyframes on these legs. I'm not gonna do too much now, but well, yeah, it's not really looking that great. If you were to animate this guy, then, I mean, he would try and do the thing that you're asking him to do while he's lying on the ground. So if you were to give him a run cycle, he would try and run while he's sort of lying in the pool of other characters. But yeah, that's pretty much it. There's no more tricks other than that. You can add, more characters. Like if you add a dog character as well, then because the force is like a global force that affects everything, it's going to affect the dog character as well. So now we have a pile of humans with a dog somewhere. There he is. Yeah, somewhere in there. There's a dog as well.